Welcome everybody to Civil Mech Maths Concepts channel. It is run by me. 2 days back, I have given a solution for the curved surface hydrostatic forces on the curved surface, and we have resolved the horizontal and vertical forces, and we found out the resultant force. We had completed in fluid mechanics properties of fluids and types of fluids, hydrostatic forces on the fluids, pressure measurements, instruments, and also pressure calculations. On the basis of all these, and in future also, I will be going with the MCQs made by me relevant to GATE, SSC JE, and also UPSC Engineering Services examination or various public sector examinations. I want to go in the subject along with the explaining of the MCQs, multi-choice questions. We learn the fluid mechanics with multi-choice questions, and relevant topics, relevant subject matter is discussed along with the multi-choice questions we deal with. We go slow and we get the concept and we solve the multi-choice question. It may not be directly from the UPSC or directly from the GATE or directly from the SSC JE, but it will be relevant to that subject, and direct questions you will be able to solve very easily once you are thorough with the multi-choice questions, different types of questions being asked, which I deal with. I try my level best to deal with all types of multi-choice questions being asked in the examinations. As a first lecture for MCQs in fluid mechanics. Fluid mechanics is FM and hydraulics. In SSC JE for civil engineering, this subject is called as hydraulics. In mechanical engineering, it is called as fluid mechanics. In GATE, it is called as fluid mechanics. So that you will not get confused, I have given both the names, fluid mechanics and hydraulics, both are same. And in this particular lecture, I will be dealing with the properties of the fluid mechanics. I have taken 1 or 2 properties here, and I have taken some 3-4 multi-choice questions. I will explain them in detail so that you will appreciate. It is not the end of the properties lecture. This will be going on, and we slowly try to complete the syllabus as we move ahead. And in MCQs, the first MCQ, first 3 MCQs I have dealt. I have given very good MCQs which you will appreciate, and one of the MCQs is, if viscosity mu is represented by force F and momentum P, it is not pressure, it is a momentum, and density rho, which are to the power of A, B and C, then what will be the value of A, B and C when you represent viscosity? The property of fluid mechanics or the property of the fluid in which we deal. This is one of the questions. Now let us delve into the questions. Question we deal with is, there is a no slip condition. A fluid is there. There is a condition called no slip condition for a fluid. It is due to certain properties of the fluid. It is due to certain behavior of the fluid. We want to know what about it. What is about it? The question is, it is made by me. The question is, the no slip condition of a fluid is due to what? The no slip condition of a fluid is due to what? Is it due to surface tension, or is it due to boundary layer formation, or is it due to viscosity, or no slip condition doesn't occur at all in fluid motion. These are the four alternatives are given to you either in the staff selection JE examination or in GATE examination or UPSC ESE examination. We have to answer it correctly. It's a question which is relatively correct. You try to understand. All the answers look like they are correct, but relatively one of the answers is more correct. That's what we have to pick up. Here, no slip, what is the no slip condition? First we have to understand that. Please try to understand the no slip condition. A fluid is there, it's moving on the solid surface, fluid is in motion, this is the solid surface whose surface is fixed and fluid is moving like this. And the velocity profile will be like this. This is the velocity profile which I have explained in my previous classes. I will give the link to the previous lectures also along with this video in the description. You can see the previous lectures on velocity profile. But I will explain here everything so that it will be self-sufficient. If you want further knowledge, you can see my other videos. But it is better if you see those videos also. They are longer videos, they are not on MCQs. This is the velocity profile. This velocity between the solid surface and the fluid surface. If the velocity of the solid surface and the fluid surface is same, solid is equal to velocity of fluid, then it is no slip condition. If the surface is a fixed surface, then velocity of solid is equal to 0, velocity of fluid is equal to 0. That means there is no difference between the velocity of the solid and velocity of the liquid or velocity of the fluid, because air is also a fluid under no slip conditions. This condition is well explained in boundary layer formation. Yes, to some extent. In boundary layer formation, whenever you see the lectures on it, whenever you read about it, in the boundary layer formation, we feel or we sense or we understand the no slip condition. But is it the property? Is it due to because of the boundary layer formation only? We have to see it. Does not occur, no slip condition does not occur when fluid in motion. That's a wrong answer, because with the velocity profile we understood that there is a no slip condition occurring. Now, is it due to surface tension or viscosity or boundary layer formation? Because this mechanism is taught to some extent comes under the boundary layer formation phenomena, but still it is not fully due to boundary layer formation. Boundary layer formation is a phenomena. Now, this is, we can say, partially correct, not fully correct, partially. Now, surface tension. You try to find out about the surface tension. Surface tension is due to forces between the surfaces, liquid surface and solid surface, and nothing in motion there. Hence, this answer is not correct. Next answer is viscosity. You see here elimination method, because no slip condition occurrence can be of various reasons. We are finding the best reason possible. We are not denying other reasons are not possible. Best reason is because of the viscosity. Viscosity is the resistance to flow. It is dominant. I never say that boundary layer formation does not create a no slip condition. It happens, but not as a property, as a phenomena. But when you see the property of the fluid, and if you want to define the property of a fluid because of which no slip condition happens, viscosity is the more correct answer. Hence, when you put viscosity as the alternative, you will get full marks. Boundary layer formation is partially correct. Surface tension is wrong. Does not occur when fluid in motion is wrong. Please try to analyze the given question and answer it. Don't just jump because you have seen in the boundary layer formation, boundary layer theory in some chapter in a fluid mechanics textbook and say that because of the boundary layer only no slip condition happens. No. Please don't do that. Please try to analyze and answer. Next question. Let us go to the next question. Question number 2. What is it? Out of 5 laws are given here. Gas laws, perfect gas laws, you may be knowing about them. PV is equal to nRT. You are aware from your 11th class, 12th class, 10th class studies. Perfect gas laws. Newton's laws, you are aware, first law, second law, third law. Conservation of momentum, you know, conservation of mass, conservation of energy, conservation of momentum. And principles of angular momentum, you know. There is a rotational motion. Angular momentum also you are known, you know, in the mechanics. These are all the topics of mechanics except gas laws, which are ideal gas topic. And laws of thermodynamics, it is pertaining to thermodynamics. Out of these 5, fluid mechanics deals with what? Which of the following laws are applicable to fluid mechanics? Which are the laws applicable to fluid mechanics? First answer is, sorry, it is given as E F G H, it is A, B, C, D. I will correct in the next presentations whenever I give. Now, 1 and 3 only, perfect gas laws and conservation of momentum. That's what alternative 1 A says. Perfect gas laws are definitely applicable because gas is also a fluid. Fluid means don't think that it is liquid only. Gas is also a fluid. Air is a fluid. Hence, this is applicable. Now, let us see whatever are applicable. Now, we know conservation of momentum. In bending of the pipes, a fluid moves like this in the curvature, in the bendings. What happens? It moves with a velocity of v1 and it deflects with a velocity of v2. And there is some amount of conservation of momentum in the process. This is conservation of momentum is applicable. Then angular momentum, whether it is applicable or not, let us see. Angular momentum is also applicable because rotation of the fluid is there rotation of fluid is also possible, because what happens when you take a fluid, water, and rotate the glass, that's rotating. Angular momentum is there. Yes. When momentum is there, conservation is there. Principles applicable. Then laws of thermodynamics. You just see the surface tension, density vary with temperature. Whenever temperature difference is there, then there comes the thermodynamics. Thermodynamics deals with the heat and temperature. Yes, this is also hot fluid, cold fluid, density of the fluid, viscosity of the fluid that changes with temperature. Hence, laws of thermodynamics are also applicable. Then ultimately next comes Newton's laws. Force is equal to Ma, F is equal to Ma. Yes, stresses are there. Stresses are there. Pressures are there. Pressures, stresses, these are all calculated in fluid mechanics. In the last previous classes, if you see, I have shown how to calculate the pressure and what are the units of pressure and how to do it. So that all these 5 laws are applicable. Answer is all of the above is correct. People may be tempted to answer for 1, 2, 3 and 5, thinking that angular momentum is not applicable. No, angular momentum is also applicable. Rotation of the fluid is there. Sometimes people may think, somebody may think laws of thermodynamics is not applicable, but it is applicable. That means all the laws are applicable as far as fluids are concerned in fluid mechanics. We deal with all the laws in the fluid mechanics. This is the introductory class of the fluid mechanic properties. And next we will be moving on to another important question. Now we will move on to the most important question, which is involving dimensional analysis with the properties of the fluids. It's a very important topic in fluid mechanics. We will develop the prototypes on the basis of this by using the dimensionless numbers such as Reynolds number, Froude number, Weber number. And as far as this question is concerned, we know that usually MLT being used as fundamental units for finding the dimensions of a physical quantity. Here the question is, if a force F, density rho and momentum P is not pressure, here I have taken momentum as the P, are taken as base units. Please see, PC is, people should not jump to that it is only pressure. Momentum is also represented in the small letter P. Base units, to confuse the students, examiner in the examination they give like this. You should not get confused that by seeing the small p you should not say it is a pressure. It can be momentum also. Then the fluid property viscosity is denoted by, answer A is F to the power of minus half, P to the power of half, rho to the power of half. B, F to the power of half, P to the power of minus half, rho to the power of half. C, F to the power of half, P to the power of 0, rho to the power of half. D, F to the power of minus half, P to the power of half and rho to the power of 0. We have to find out which one is correct. What are the dimensions of which quantity we have to find? It is viscosity, mu. It is dynamic viscosity. There is another quantity called kinematic viscosity also. Mu by rho is equal to kinematic viscosity. It is dynamic viscosity. You may be knowing the number, a dimensionless number, Reynolds number, usually used in dimensional analysis for developing the prototypes regarding viscous forces. Reynolds number is rho v d by mu. As far as dimensions are concerned, because it is a dimensionless number, the dimensions of Re will be 1 and the dimensions of rho v d by mu will be 1. That means dimensions of rho v d is equal to dimensions of mu. That means dimensions of viscosity will be equal to dimensions of rho v d. Now, here rho is the density. Density is in kg per cubic meter. That is equal to m L to the power of minus 3. Force F. Force is equal to mass into acceleration. That is m into L into t to the power of minus 2. Acceleration is meters per second square. Next P. That is momentum. Please remember, if it is given as a momentum, take it as a momentum only, don't take it as a pressure. Momentum is mass into velocity, that is equal to m into L into t to the power of minus 1. Now, mu is nothing but, what is rho? M into L to the power of minus 3. V is velocity, L into t to the power of minus 1. D is diameter, diameter is L. That means dimensions of mu is equal to m into L to the power of L square into L to the power of minus 1 is minus 3 is L to the power of minus 1 into t to the power of minus 1. This should be equal to force to the power of A into momentum to the power of B into rho to the power of C. We are not aware what is the value of A, what is the value of B and what is the value of C. This is equal to what is force? ml into t to the power of minus 2 into A. P is momentum is ml t to the power of minus 1 into B into density is ml t to the power of minus 3 t to the power of 0 to the power of C. That means ml to the power of minus 1 to the power of minus 1 is equal to m to the power of here A, here B, here C. A plus B plus C. A plus B plus C, m. Then next into L. L, what is happening? L to the power of A, L to the power of B, L to the power of minus 3C. L to the power of A plus B minus 3C. Next, T to the power of minus 2A minus B plus 0. When you compare the powers of m, A plus B plus C is equal to 1, which implies A plus B plus C is equal to 1. When you compare the powers of L, A plus B minus 3C is equal to minus 1. When you compare the powers of T, that is minus 2A minus B is equal to minus 1. These are the three equations, three unknowns. You try to solve them as a homework. Now the problem is solved. A plus B plus C is equal to 1, A plus B minus 3C is equal to minus 1, minus 2A minus B is equal to minus 1. From this we get the answer as A is equal to half, B is equal to 0 and C is equal to half. From this, f to the power of A, answer is f to the power of A P to the power of B into rho to the power of C is equal to f to the power of half P to the power of 0 and rho to the power of half. This is the answer. What is the answer here? C is the answer. If you see, C is f to the power of half, P to the power of 0, rho to the power of half. This much homework is to be done before getting the correct answer. This is very, very important as far as properties of fluids are concerned. Fluid mechanics is based on the properties, dimensions and units. Very important topic. Then I thought, let me take this as one of the topics for one of the questions as MCQ for your understanding. This type of MCQs, they come in GATE examination, they come in staff selection JE examination, they come in engineering services examination ESE, UPSC also, and they have come also. This is a question made by me, but this type of questions do come. You please follow this type of procedure and solve the question in the examination. Best of luck to all of you. Thank you for listening to me. Thank you for viewing my lecture. If you feel there is a value addition because of this lecture to you, you please subscribe to my channel Civil Mech Maths Concepts. Please subscribe to my channel, share and view other videos of my channel also. Thank you. Best of luck to you.